Hi class. Today our topic of discussion is integral from class 12. Let us first understand what do you mean by integration. Now, integration in layman's word is nothing but antiderivative, antiderivative, or you can say it is the reverse of differentiation. What do I mean by this? Suppose you differentiate a function capital Fx and the result small fx. So integration is a process by which if you integrate the result, you should get the original function, which means this is the sign for integration. If I integrate the result dx, we will get the original function plus c. The c denotes the integration constant. Okay, fx was a result. This is known as integral. Okay, this small fx was the outcome of the ddx. This is known as integrand, and of course dx represents that the variable of integration is x. Variable of integration is x. How this constant came, I'll explain the entire thing. For example, we take an example. Look over here. Just look at this. Suppose I say ddx of sine x. We know ddx of sine x is cos x, which means integration of cos x dx will be sine x plus c according to the definition. Now, how does c came? Look over here. ddx of sine x is cos x. If I write ddx of sine x plus 2, still cos x. If I write ddx of sine x plus a, suppose a is a constant, still we get cos x. So in all the three cases, the outcome is same. So if you write that integration of cos x dx equals to sine x, we don't know which was the original function, whether it was this, or this. So we write plus c. So this becomes indefinite, isn't it? Because c can have any value, indefinite value, indefinite value. Am I clear? So this entire thing is your indefinite integrals. Indefinite integrals, because we have indefinite numbers of solution because of the constant. Am I clear? Now look at some elementary standard integrals which we can know if we know the differentiation of a function. What I'm speaking about, just look. We know ddx of, suppose I have x to the power n plus 1 by n plus 1. How do you differentiate this? The power comes in the front, so n plus 1. X to the power reduces by 1 by n plus 1 was a constant. So this goes away. This becomes x to the power n, and of course n not equal to minus 1. So ddx of x to the power n plus 1 by n plus 1 is x to the power n, which means my first standard integral, integration of x to the power n dx, is nothing but this x to the power n plus 1 by n plus 1 plus c. Similarly, see this one. ddx of log x is what? 1 by x, which means my integration of 1 by x dx will be log mod x plus c. Am I correct or not? See the third one, ddx of x is 1, which implies integration of 1 dx, or simply integration of dx will be x plus c. Am I clear or not? Look at the fourth one. I'm now writing the direct thing, okay? Integration of e to the power x dx will be e to the power x plus c. Why? Because differentiation of e to the power x is e to the power x only. Look at number 5. Suppose we have integration of cos x dx. Of course, this will be sin x plus c. Am I clear or not? Because ddx of sin x is cos x. Similarly, if you have integration of sin x dx, now integration of sin x dx will be minus cos x plus c. Why minus? Because we know ddx of cos x is minus sin x. Am I clear? Now look at number 7. Integration of sec square x dx will be nothing but tan x plus c, because ddx of tan x is sec square x. Number 8. Integration of similarly cosec square x dx. This will be what? Minus cot x plus c. Am I clear? Now look at number 9. If you have integration of sec x tan x dx, this we know will be sec x plus c, because ddx of sec x is sec x tan x. Similarly, these are all I'm getting it by derivation. If I know the derivative, I know the integral also. Suppose cosec x cot x dx. This will be minus cosec x plus c. Am I correct or not? Okay. Then look at number 11. If I tell you integration of, suppose, 1 by root over 1 minus x square dx. Now we know this will be sine inverse x plus c, because ddx of sine inverse x is 1 by root over 1 minus x square. Look at the next one. Similarly, if I have integration of 1 by 1 plus x square dx, this we all know will be tan inverse x plus c, because ddx of tan inverse x is 1 by 1 plus x square. These are some of the standard integral which I'm talking about. Integration of 1 by x root over of x square minus 1 dx. We know this will be sec inverse x plus c. Look at one more, I missed it. I should have told this earlier only. Integration of a to the power x dx. This will be a to the power x by log a plus c. Because if you differentiate this, you'll get a to the power x. Look how. If you differentiate ddx of a to the power x by log a, we know ddx of a to the power x is what? A to the power x log a by log a, which means ddx of a to the power x by log a is nothing but a to the power x. which means integration of a to the power x dx will be a to the power x by log a plus c. Am I clear? Now look at two properties before we start the exercise. Look at P1, property 1, integration of k fx dx, where k is a constant, okay? This becomes k comes outside like we used to do in derivation, integration of fx dx. Is it clear? Property 2, integration of, suppose you have function fx, then you have plus minus gx dx. This will be equal to be separated and integrate, which means integration of fx dx plus minus integration of gx dx. Remember, not applicable for multiplication, which means integration of fx gx dx not equal to integration of fx dx multiplied by gx dx. We can't do like this. Am I clear? Now let us look at the sums from exercise 8.1 and 8.2 from ML Agarwal. Now look at sums from exercise 8.1, 1 part 1, integration of x to the power 5 dx. We have the formula x to the power n dx is x to the power n plus 1 by n plus 1 plus c, which means this will be x to the power 5 plus 1 by 5 plus 1 plus c, which is x to the power 6 by 6 plus c. Clear? Part 2 is the same. Look over here. Can I write this as x to the power minus 3 dx, which on integration gives you x to the power n plus 1 by n plus 1 plus c, which is equal to x to the power minus 2 by minus 2 plus c, which is minus 1 by 2x square plus c. Done. Now look at 2 part 2. Very easy. Look over here. Integration of sine square x cos square x dx. Now sine and cos are reciprocal. So this I can write integration of dx only. And integration of dx is what? X plus c. Done. Now look at 4 part 2. Integration of 7 to the power x e to the power x dx. This we know. We can write this as 7 multiplied by e to the power x dx. Now this is in the form of integration of a to the power x dx. We know this will be a to the power x by log a plus c. Am I clear or not? Now look at 4 part 3. Can I write this as integration of 4 to the power x by 9 to the power x? Can I write 4 by 9 to the power x dx? Again, this is in the form of integration of a to the power x dx, which is a to the power x by log a plus c. Am I clear? Look at this. Integration of sine by 1 minus sine square x. Now this, if you look carefully, can I write this as sine x by cos square x? I missed the dx over here. Okay, and this is nothing but sine by cos is tan x, and 1 by cos x still remains over there, so that becomes sec x dx, and integration of sec x tan x dx is nothing but sec x plus c. Then look at 5 part 2. Integration of 5 to the power 2 log x base 5. Now this, by using the property of logarithm, can I write, again I missed dx over here, can I write 5 log base 5 x square dx, which by using the property of logarithm, this becomes x squared dx. Now, we know the integration of this. This will be x cubed by 3 plus c. Done. Now, let us look at the other exercise, 8.2. To look at exercise 8.2, sum number 3 part 2. Integration of 2x square minus 3 sin x plus 5 root x. Now, can I write this as integration of 2x square dx minus integration of 3 sin x dx plus integration of 5 root x dx? Now look carefully, 2 is a constant, it comes out, and x to the power n, it will be x to the power n plus 1 by n plus 1, isn't it? 3. Integration of sin x, we know it is minus cos x plus 5 comes out. Integration of root x is nothing but x to the power half, so it will be x to the power half plus 1 by half plus 1 plus c at the end, constant. Am I clear? Now look, this is equal to twice, this is x cube by 3 plus 3 cos x plus 5. This becomes x to the power 3 by 2 by 3 by 2 plus c. Am I correct or not? Which means your final answer will look something like 2x cubed by 3 plus 3 cos x plus this 2 goes up, 10 x to the power 3 by 2 by 3 plus c. Okay, now let us look at 4 part 2. Integration of x square 1 minus 1 by x square dx. Pretty easy, just open the bracket. So this becomes integration of x square into 1 is x square minus x square into 1 by x square is 1. Am I clear? Now look, integration of x square, x to the power n is x to the power n plus 1 by n plus 1 minus integration of dx, 1 dx, which means integration of dx. Integration of dx, I told you it's x minus x plus c, which means this becomes x cubed by 3 minus x plus c. Clear? Now look at 6 part 1. Same manner, we'll just first open the bracket. So this becomes integration of root x minus x root x dx. Am I clear or not? Now, this is nothing but x to the power half minus and x multiplied by root x, which means x to the power 1 multiplied by x to the power half. So it's x to the power 1 plus half is 3 by 2 dx. So that becomes integration of x to the power half is x to the power half plus 1 by half plus 1 minus x to the power 3 by 2 plus 1 by 3 by 2 plus 1, which is equal to x to the power 3 by 2, isn't it? In the denominator 3 by 2, so the 2 goes up. Over here x to the power 5 by 2, in the denominator again 5 by 2, so 5, 2 goes up plus c. Am I clear? Now look at 10 part 1. Integration of 1 minus sin x by cos square x dx. Now this, can I write it like integration of 1 by cos square x minus sin x by cos square x dx, which becomes integration of c sec square x minus this is tan x sec x dx. Now integration of sec square x is nothing but tan x minus integration of sec x tan x is sec x plus c. So that's your answer. Okay. Now let us look at the next sum. Now look at 10 part 2. Integration of e to the power 6 log x. Now e to the power 6 log x, can I write e to the power log x to the power 6? Similarly, e to the power 5 log x, can I write e to the power log x to the power 5? Look carefully. Similarly, this will be e to the power log x to the power 4 minus e to the power log x cube dx. We know the property of log. This becomes x to the power 6 minus x to the power 5 by x to the power 4 minus x cube dx. By using the property of log, this, if you take x to the power 5 common, that's x minus 1 and x cube taken common, x minus 1 dx. Of course, x not equal to 1, this. What remains is integration of x squared dx, which is nothing but x cube by 3 plus c. Am I clear? Now let us see 12 part 1. Integration of cot x by sin x minus tan x by sec cos x minus 3 tan square x. Can I write this as, carefully, can I write this as cot x cosec x minus tan x sec x minus 3 times tan square x. We know tan square x is nothing but sec square x minus 1. Am I correct or not? Dx of the entire thing. Now look carefully. This is integration of cot x cosec x minus tan x sec x minus 3 sec square x minus 3 dx. Am I correct? Now we know integration of cot x cosec x is minus cosec x minus tan x sec x is sec x, isn't it? Minus thrice. Integration of sec square x is tan x minus 3. Integration of dx will be x plus c. So that's your solution. Am I clear? Now let us look at 12 part 2. Very easy. Look over here. Integration of 2 minus 3 sin x by cos square x dx. Now this I can write, see, 2 by cos square x is nothing but 2 sec square x minus 3. Sin by cos will be tan x sec x. Am I clear or not? Dx, which means this will be twice. Integration of sec square x is nothing but tan x minus thrice. Tan x sec x is sec x plus c. That's your answer. Now look at the next sum. Now let us see 13 part 1. Integration of 1 by 1 plus cos x dx. What I'll do, rationalize the denominator. So on rationalizing the denominator, what I'll get? This was your original question. So I'll multiply by 1 minus cos x, the numerator and the denominator, isn't it? So this becomes 1 minus cos x by 1 minus cos square x dx, isn't it? Which becomes, see, 1 minus cos x dx by sine square x, which becomes, see, 1 by sine square x is cosec square x minus cos x by sine square x is nothing but cot x cosec x dx. Am I correct or not? Now we know the integration. Integration of cosec square x is minus cot x minus integration of cot x cosec x is minus cosec x plus c. So it will be minus cot x plus cosec x plus C. That's your answer. Let us look at 15 part 1. Integration of root x minus sine x by 2 cos x by 2 plus 5 days. Look carefully. Can I write this as integration? What I'll do, I'll multiply the 2 with the numerator and denominator of sine x by 2 cos x by 2. How does it help us? This is root x. And if you look carefully, 2 sine x by 2 cos x by 2 is nothing but sine x some multiple plus 5 dx. Am I correct? Now we'll do the integration. Integration of root x. We know x to the power half is what? X to the power half plus 1 by half plus 1 minus sin x integration is minus cos x by 2 plus 5. Integration of dx will be x plus c. Am I correct or not? So this is x to the power 3 by 2. In the denominator 3 by 2, so 3, 2 comes over here plus cos x by 2 plus 5x plus c. Any doubt? I don't think so. Now look at 15 part 2. Integration of cos 2x by sine square x cos square x dx. Can we write this as, we know cos 2 theta is cos square x minus sine square x, isn't it? By sine square x cos square x dx, which when we solve cos square x by the denominator will be 1 by sine square x, which means cosec square x minus sine square x by the denominator, which means sine square x cancels out. This is sec square x and a dx over here, which means cosec square x integration we know that's minus cot x minus sec square x integration we know that's tan x plus c. Am I clear? Now let us look at the next sum. Now look at 16 part 1. Sec x by sec x plus tan x dx. Very easy. We'll rationalize the denominator. When we rationalize the denominator, we know we need to multiply the denominator and the numerator with sec x minus tan x, isn't it? So after rationalizing, I think the entire thing changes to, if you look, sec x minus tan x dx, and in the denominator you have sec square x minus tan square x, isn't it? Which means this becomes sec square x minus sec x tan x dx, because in the denominator sec square x minus tan square x is 1. Now integration of sec square x is tan x minus sec x tan x is sec x plus c. Done. Look at 18 part 1. Very easy. Integration of root over of 1 plus cos 2x is nothing but 2 cos square x dx, which is integration of root 2 cos x dx, which means root 2 comes outside. Integration of cos x is sine x plus c. Am I clear? Look at 19 part 1. Integration of cot inverse sine 2x by 1 minus cos 2x. What we'll do, we'll try to simplify the thing inside the bracket and get in term of cotangent or cot. Look over here. This I can write cot inverse. This is 2 sine x cos x, and 1 minus cos 2x is 2 sine square x dx. So how it changes? Look over here. Cot inverse, and this becomes, look carefully, this becomes cot x, isn't it? This changes to x ds, inverse trigonometric function we have done, and this is equal to x square by 2 plus c. Am I correct? Now look at the last sum, 20 part 1. Similar. We'll try to solve it and bring it in tan form. So this is tan inverse integration. We can write 1 by sin x minus cos x by sin x dx. which is integration tan inverse. If you take the LCM, this is 1 minus cos 6 dx. Now we'll do the sum multiple formula. You know, this is tan inverse 1 minus cos x will be 2 sine square x by 2, isn't it? And sine x, can I write 2 sine x by 2 cos x by 2? Look carefully, dx. So this. So what remains? It becomes integration of, if you look carefully, tan inverse, and inside the bracket, if you see, this is tan x by 2 dx, which becomes integration of x by 2 dx. So half comes outside. Integration of x is x square by 2 plus c, which is x square by 4 plus c. And that's the last sum. In the next video, we'll see integration by substitution, which is very important. Okay, till then, take care.